Sample problem 4.8 asks us to predict whether or not a reaction occurs when each of the following pairs of solutions are mixed. If a reaction does occur, write balanced molecular, total ionic, and net ionic equations and identify the spectator ions. So A part says we have potassium fluoride plus strontium nitrate. And the first step is to convert those names into chemical formulas. Okay, so potassium fluoride is going to be Kf, right? Because potassium from the periodic table has a +1 charge. Fluoride has a -1, so I just need one of each of those. That's going to be Aq plus strontium nitrate. Strontium is Sr with a 2+ charge. Nitrate is NO3 with a -1 charge, which means I'm going to have two of those, right, to counteract the +2 on the strontium. Now, if you notice over here in the bottom right corner, I have this little table down here. And I'm going to look at this table now because this is how we determine if a reaction is going to occur. This is a precipitation type possible reaction, and we just have to decide if it's going to happen or not. So let me zoom in on this table here. Okay, and this is going to tell us whether or not something's soluble. These are called the solubility rules for ionic compounds in water. And so I'm going to go through this really quickly. We have potassium and fluorine. This is the cation, this is the anion. Here we have strontium and the nitrate. This is the cation, this is the anion. So what we do is we have to take the cation of one and pair it with the anion of the other. And then this cation gets paired with this anion. And then we check the solubility rules to see if something is insoluble. If it's insoluble, it will be a precipitation reaction. If all the things are soluble, I'm not going to get a solid to precipitate out of the solution. Everything's just going to remain ions in the solution. So here we go. Potassium and nitrate. That's going to form potassium nitrate. So I look, and I have rule here for potassium, right? It's a group 1A metal, and it's right here, and it says that all of these are soluble with no insoluble exceptions. So if I were to then write that as my first product, let me move my solubility rules out of the way and go back to my problem here. Potassium nitrate. I would say that is Aq. It's aqueous because it's not going to be insoluble. It's going to be soluble. All right, so now let's check our strontium. Do we have a rule for strontium? Or nitrates even, right? Let's see. Because I'm going to have strontium pairing with fluorine, right? Those two, strontium and fluorine. So let's see. Strontium is a group 2, and let's see, fluorine is halogen. So what do I have here? All common, here we go. I have one for fluorides here. It says all common fluorides are soluble, right, except for lead fluoride and fluorides of group 2A. So is strontium lead? No. Is strontium a group 2A metal? Yes. So since I answered yes there, this is going to be insoluble. So when I pair strontium and fluorine together, they're going to form a precipitate or a solid. Okay? So let's see. Let me move this over here so I can have more room to write. So strontium, remember strontium has a positive 2 charge, and fluorine has a -1, so that means I'm going to have two of those. And I'm going to give this a solid physical state, and that's going to be my precipitate. So yes, a precipitation reaction this is. Now let's see. Now we have to balance it because that's the next step. It says if a reaction does occur, write the balanced molecular equation first. So let's see. I've got one potassium, one fluorine, 2 fluorines. Uh-oh. How am I going to fix that? I'm going to put a 2 right there, right? Which means now I have to put a 2 there. All right, now let's keep checking these things. So now I have 2 potassiums, 2 fluorines, 2 fluorines, 1 strontium, 2 nitrates, 2 nitrates. So this is balanced. The next step is to write the total ionic. A total ionic equation means that I'm going to break up soluble things into their ions, and I'm going to leave insoluble things together. So let me explain to you what I'm talking about. I've got to determine, is potassium fluoride soluble? Now I could just say yes it is because I know the physical state of it, it's aqueous, right? Anytime you see this AQ, you know it's soluble in water. But we could also check the solubility rule. So let me see. I've got potassium here, right, a group 1, and it says they're all soluble with no exceptions. So that means when I'm writing the ionic equation of this thing, I've got to break it apart into its ions. So I'm going to have 2K plus ions, and that's going to be AQ, plus 2F minus ions, and that's going to be AQ, plus strontium nitrate again, and I didn't put that it was aqueous a minute ago, and I should have. There we go. It's going to be soluble, and if I check the solubility rules for nitrates, check it out. All common nitrates are soluble, no exceptions. So I'm going to break that apart into its ions. I'm going to have plus strontium with a 2 plus charge, and I'm going to give it the AQ, physical state, plus my 2 NO3s, right, my 2 nitrates with a negative charge, AQ. Yields, so that's all my reactants. Now I got to do the same thing for products. We already determined that potassium nitrate was soluble, so I'm going to come down here and put my products. So 2 potassiums, and that's AQ, plus 2 nitrates, and that's also AQ, plus we decided that our strontium fluoride was insoluble, so it stays together. I don't break it apart. SrF2 solid, solid, there we go. All right, so there's my total ionic equation. Now I have to identify my intermediates. And an intermediate is something, or I'm sorry, not an intermediate, a spectator ion. A spectator ion is something that appears on both sides of the yield arrow in the same format, okay? So I've got 2 potassium AQs. On the left of my arrow, I've got 2 potassium AQs on the right. That's my first spectator ion. Now I have 2 fluorines on the left, but I do not have 2 fluorine ions on the right? It's paired with strontium on the right. That's insoluble. I've got a strontium ion on the left. I do not have a strontium ion on the right because, again, it's paired with the fluorine, insoluble. I do, however, have 2 aqueous nitrates on the left and the right. So there are my spectator ions. So I've identified those. The next step is to write the net ionic equation, and though that equation includes everything except for spectator ions. So I'm going to bring everything down from the total ionic that was not a spectator. So that's 2 fluorines plus strontium yields strontium fluoride. All right? And we have to do the same thing for B part now. I'll first have to decide, is a reaction going to occur? So let's see if one's going to occur or not. I have ammonium perchlorate, and remember, ammonium is NH4 with a +1 charge. Perchlorate is ClO4 with a -1 charge, so I just need one of each of those, and that's going to be AQ, plus sodium bromide, NaBr, right? Sodium has a +1 charge, bromine has a -1 charge. That's going to get the AQ. All right, and now I've got to decide, based on solubility rules, is that thing right there going to react? Am I going to have a precipitation reaction? All right, so let's look at the solubility rules really quickly. For ammoniums, perchlorates, sodiums, bromides, let's see. So right here I see sodium first in the first solubility rule listed. It's a group 1 metal, soluble, no exceptions. So sodium perchlorate is going to be insoluble. That's my first product, so let me go ahead and write that down here. So plus sodium NaClO4 AQ plus, let's see here. Do I have a rule for my ammonium bromide, right? Oh, here we go. All common ammoniums, right? All common compounds of ammonium, soluble, no exceptions. So what does that mean? That means that B, there's not going to be a reaction whatsoever. So let me go ahead and write this down. it would be NH4, NH4Br. That would be aqueous, AQ. I'm going to put an X through that because no reaction. I will not form a precipitate in that reaction based on solubility rules.